Greengrass is one another service from AWS, which is like very interesting, very important. And why is it? Just like how I concluded my dialogue in the previous service, which is like these two devices should not have had to send data all the way to the cloud. Why can't there be like a local gateway or a edge computing device that does all the local communication, so these devices don't have to send data all the way to AWS IoT core for every simple thing. So Greengrass is like it brings some of the AWS services to the edge. So on-premise network, let's say there are like multiple devices, and if we want these devices to talk to each other or do some kind of local storage or things like that, we can easily have a Greengrass group where we can configure it to do certain things. So basically we can like the Greengrass service, it has a core. The core gets installed into one of the computers. It can be a Raspberry Pi, it can be a Linux computer, it can be in a container if it is like a Windows computer or a Mac computer. So stuff like that. We can have a Docker container and then we can have the core in it. Now, the core is what has those AWS functionalities. So it can run something like a Lambda function. We can have local subscriptions. So if the devices locally wants to talk to each other or devices needs to trigger Lambda function, they can do that. And then we can have resources like if we want to do some kind of local machine learning inference, we can do that as well. And then there are connectors. So if we want to model the data, there are like if there is like AWS's other services that Greengrass needs to talk to, or third-party services that the Greengrass core needs to talk to, uh, the connector will create that interface for it. Now, all of these things put together is what we call as a Greengrass group. So within a Greengrass group, there's going to be only one core. Every Greengrass group has only one core, and it can have any number of Lambda functions devices. Not any number, like 200 devices. Lambda functions, I'm not really sure, but we can have subscriptions so that these devices talk to other devices. These devices talk to the core. These devices talk to Lambda function. The devices talk to AWS IoT core and stuff like that. So all of these things can happen very easily. Okay, an example of IoT Greengrass, we can have things like this, which is like on-premise network. There can be factory equipment, PLCs, windmill, OPC, UA servers. There can be like all those devices that generates the data, and then they can send that data to the Lambda function that's running on the Greengrass core. So it can do some kind of preliminary work on the data that it has got, and then it goes to AWS Greengrass. The Greengrass can have like local storage, or it can further forward it to IoT core. So whatever, I mean, not every data needs to make its way into IoT core. In our example, we know that the environmental sensor data, maybe we wanted to store it. So it makes sense if we put it to IoT core. Or even that one, if we are reading it in a very high frequency, we can like aggregate it and then we can send once in a minute. Stuff like that as well we can do. So we can have like a local compute in Greengrass, do all that stuff, all the aggregation, and then send the consolidated information to IoT core. So that thing we can do with Greengrass. We can run local inference of machine learning and stuff like that. And IoT core can have like those rules with which it can trigger a Lambda function, put it to DynamoDB, store it in S3, or it can run the job request so it updates the IoT devices. Stuff like that can happen easily with Greengrass. Now, I have like a Raspberry Pi. We will see like how quickly we can install the Greengrass core in it. There are two versions of Greengrass. One is I mean, it started with Greengrass version 1, which is the classic one. Recently Greengrass 2 has also come up. Greengrass 1 is like while learning, Greengrass 1 is very helpful to understand the concept, so I will stick to the V1 for now. So currently I'll go to Greengrass groups, and there's like currently no group in here. So I'll create a group. Let me, okay, default creation, and let's call this my home Greengrass group. Okay, my home triple G, that's the group name that I'm giving it. And then I'm clicking on next. The core name, the group name is my home triple G. The core device's name will be my home triple G core. This is also one of the IoT devices. So once we complete all these steps, my home triple G core will become like one of the things in the manage tab. Okay, I'll click on next. Now it will create the group, it will provision all of those things, and click create group and core. It does all of these things, which is like set up it in the cloud. Okay, once it has done all of that, it asks me to download all these resources, the 3 certificates, and then core specific configuration file. Let me click on that and then I will go to certificates and then let's call it my home triple G core create, and then in there I'm storing that zip file. And we can also download the root CA, but we will do it later on. And which platform are we going to use? Depending on is it Linux or Raspberry Pi or any Microsoft, I mean Docker, it gives us like different software to install. So for Raspbian, we have 7L, which is the latest one. So I'll click on downloading this one. Now I'll store it in the same place as where I have stored that setup.gz. So save it. Okay, that has got saved. And okay, the save storing is done. Now I'll quickly on turn on my Raspberry Pi. So this is like a fresh Raspberry Pi 4. All I have done is like installed Raspberry Pi OS Lite in it, and then enabled SSH, and then made it connect to my local Wi-Fi. New terminal at folder. Okay. So in this folder of mine, I have these 2 files. The first thing I will try to do is like try to connect to my Raspberry Pi. SSH pi at raspberry pi dot local. Okay, and then I connect to it. You can see that it has like no ports open. It has only port 22 for the SSH, and it does not have any files in this one right now. Now we will go through this uh, manual to install Greengrass in this one. Okay, so we will do getting started, Greengrass device setup. So we have created it. The first thing we need to do is okay, module 1 environment setup for Greengrass, setting up a Raspberry Pi. Here it asks us to have the host name. Okay, first basically it's connecting it to the SSH. So we have done that already. The first step we need to do is like add the user and add the user group. So I'll copy this thing and then I'll paste it here. Okay, both done. So we have created a new user called GGC user and a GGC group. And then to improve security, enable hard link. The way we do it is like in this folder, we have this file called 98 rpyconf. So we will do sudo nano tc sys d 98 rpy.conf, and in here we need to add a couple of lines, which is these two. So I'll copy that, I'll paste it here, Control X, enter. So that's done. Now we need to reboot the Raspberry Pi. So I'll do that, sudo reboot. Okay, we will give it a minute, and then once the Raspberry Pi reboots, we can again log back in, and then we can run this command. When we do that, we should be able to see both these file system protected hard links and then symbolic links should be equal to 1. Okay, let me try connecting again. Okay, connected. Copy it, paste it. Here it says fs protected hard links equals 1, symbolically equals 1, which is good. So what we will do next is okay, in the boot directory, so we need to have sudo nano and then we need to add these two things in the end. So I'll go to the end and then I'll put these two values, save it. Again, we will have to do reboot. Turned on, got connected. So what we will do next is like install the JDK. And once the JDK is installed, there is a tool called as Greengrass dependency checker. We can download that tool and then we can run it so that we will get to know that whatever we need in order to have the Greengrass core or the Greengrass service running in the Raspberry Pi, is it like satisfied or not? Okay, since this has broken, let me do this sudo apt get update fix missing. Okay, it has done that. So if I do install again, it should. Okay, now that Java has done installing completely, I can copy this and then I can run it here. So it will install the dependency checker and then it tells me that Python 3.7 is working and Node.js is not found. So depending on which SDK are we running, we need to have like those programming languages. Okay, so if we want to have like Lambda functions that's based on 3.8, we need to have that. For me, it's not that big deal, so I'll leave it. Similarly, Node.js is also not something that I'll develop Lambda on or run an environment on in this Raspberry Pi, so I'll leave it. And Java 8 is not installed. So that's one of these things. When we want to have like a stream management for core, we need it. But I have had it running even without that, so I'll leave that as well. Now here it says like you can now proceed to installing Greengrass core in the device. So that's what we will do. Okay, so I'll open another tab. In here, what I will do is like, I know that I have two files in here. Both these files need to go to my Raspberry Pi. So I'll use SCP to copy these things. So copy this file to pi at raspberry pi dot local init, copy it to home pi. Here, does it work now? Yes, it does. So now I will do SCP. It asks me for password. Okay, done. So this one got copied. Similarly, I need to copy SCP and then this Greengrass to pi at raspberry. py.local home py folder. So this is getting copied, but if I look at the files here, it has got this one. This is like copying. The dependency checker is also there already. Okay, let it copy, and then we will move on to the next step, which is like installing AWS IoT configure. We did this already. So grant permission, do all of these things, which is done. So start AWS IoT Greengrass. And in this one, we will have to do this, which is, okay, we copied the files, and once we have it, we need to do this, extract both of these. So the greengrass .tar.gc, it has to go to the root directory. So let's first do that. Sudo tar xcvf greengrass linux and go to directory, home directory. So that got extracted. Similarly, sudo tar xcvf, and then whatever was the rest, it needs to go to slash greengrass. Okay, so that has gone to search and config in here. So what currently has happened is, like, if I go to root directory, there has to be a folder called as greengrass in here, and in this greengrass, cd greengrass, there has to be like certs in that. We will have the certificates of this one. It does not have root certificate yet. We will be downloading it as we go further. And there is config, there is ggc core, software, all that stuff. So we have seen this one, and then we need to do this as well, which is wget copy this and go to certs folder and run that file. So we get a root.ca.pem. So now it should have the root certificate as well here. Okay, good for us. Now come back. It has got it. And then we can go ahead and then start the Greengrass service. The way we will do is, like, all we have to do is, so cd in the root directory, go to Greengrass, go to ggc, then go to core. In there will be this file called as Greengrass SSD. That's what we need to run. The way we do run that is like sudo /greengrass SSD and then start. This will start it, and then if I look at the service, it will have, okay, currently it's opening port 8000, but it should also start port 8883 and all that stuff. Okay, the Greengrass has started. Actually, next thing, we can go ahead and then do the other stuff. Now what I want to do is, the setup is done. Now, instead of the RFID and light bulb talking to IoT core all the way, can we make them talk to Greengrass because it's local, and then we can simply deal with everything locally itself? So how can we do that? Now, in order for us to do that, what we can do is, like, come back to finish. Okay, there is this group, and within this group we can have subscriptions. So messages go from one entity to the other. There is like only one core, and currently there are no devices in this group. So what I want to do is, like, add the devices that we had already. I want to add env monitor 1. Similarly, I also want to add the existing thing, env monitor 2, and also add the RFID module and also add the light bulb. So all the four devices that were directly talking to AWS IoT Core earlier, now they will have to talk to Greengrass first. Okay, now that this is done, what I also need to do is like whenever RFID publishes any message, I want that to be going to the Greengrass core and the light bulb should be able to access that message. How can I do that? That's where the subscriptions come into picture. So what I want to do is like add a subscription, and I want this whenever RFID sends a message, I want it to go to local shadow service. Next, local shadow service as in like it will be there within the group itself. So here I can specify that which topic should it be. Reskill slash RFID slash PUD. Okay, finish. And from the local shadow, I want the messages to go to light bulb. Next, it will have to be again in the same topic. Reskill RFID slash PUB. Okay, so the messages will get exchanged this way between them. And for the time being, let's say I want the devices ENV monitor data to actually go to IoT cloud. Okay, I know that this device sends data in this topic. So I'll do this. Add one more subscription, which is send data from ENV monitor to also to IoT cloud and in this topic. Okay, so we have configured a few things, but the device software is going to change for all of these. So what we will have to do is now these devices also need to talk to Greengrass. How do we make sure that they talk to Greengrass as well? The policy needs to say that they can talk to Greengrass as well. Now, there is a workshop that AWS has created. It's called ESP32 Getting Started. Now, in this, they have, okay, it's in iot-esp32.workshop.aws. I'll put this link in the end as well as during this video as well. Now, when we want to communicate it with Greengrass, what we need to do is like give the permissions as well. So how do we give permissions? So we have to, in the setup, when we have specified the policy, we also should allow this to connect to Greengrass. So this is what we need to add. Statement effect allow, just like how we did for IoT star, we need to do for Greengrass star as well. So let me copy this thing, come back here, go to policies, where is allow all, which is what is connected to all the four devices. I'll go to that, edit policy document, and in here I will add this statement as well. So effect allow action Greengrass for all the resources. Save as new version. Okay, now our devices will be able to talk to that. But one of the things we need to change is the firmware. It should not directly connect to IoT Core. It should try to establish communication with Greengrass, and then that's how it needs to communicate with the rest of it. Okay, so what I will do now is in the same folder, whatever I have this Greengrass. In the Greengrass, there is like this ESP32 thing. So let me open it. This is like a entirely different Arduino program. Now in this one, we also use like one more library called as AWS Greengrass IoT, and we will have to specify like whatever we did earlier for this one. I'll open the previous one, and okay, the secrets thing, it's all going to be the same. So I'll just copy this and then replace this entire page with this one. I'll come back to Greengrass and then I'll just show you like how this one works. So here there is like connection to GCC. It tries to establish the connection and then that's how it communicates here. And it will have all those metrics that it sends. And here again, we are publishing with that same topic. Okay, all good. So what I will now do is I will upload this program, go to tools, ESP32 and that same device. Okay, now let's upload this one. And one more thing I had to do with this Greengrass group is like I did add 4 devices in it. I did add 4 subscriptions in it. One more thing we need to do is like click on actions and then deploy. Only when we deploy all the changes, say automatic detection, it will automatically try to connect to this Greengrass core in the Raspberry Pi and then it will have all the changes done. So it goes through like the first time it takes some time. It has an error. Greengrass is not authorized to assume the service role associated with this account. We don't really need this local shadow service because shadow service stores the state of it, so we don't need it. So it will still be running. I'm only sending these 2 values. Deploy it again. Okay. So the local shadow service is what was the trouble, but now that I have got rid of it, this is working now. Next thing what I'll have to do is I'll need to program this device. So let me upload it. And parallelly, I'll also do this. So instead of my light bulb device connecting to this host, I want it to connect to Raspberry Pi local because that's the host name of my Raspberry Pi. Since the deployment is complete, now if we look for what ports are open, here it says that port 8883 is open, which is important because for local communication to happen, this needs to be up and running. Okay, so I have put this as Raspberry Pi local, so I'll connect back my M5 Core 2 device. And since this is also uploading, I will press the button so it gets uploading. Now, if I open the terminal of my ESP32, it should tell me that connecting Wi-Fi and then Greengrass discovery. This is the IP address. Failed to connect to Greengrass. Okay, it didn't connect for a couple of times, but after that it has got connected to AWS Greengrass, and then it is also publishing messages now. So if I go back to my test client, I should be able to see the messages coming in here from my ESP32 device. So I have subscribed to all the topics, right? So ENV monitor 2 data is coming in once in every 5 seconds. Okay, now that this is like working fine for us, let me close this, and I will also change the program for this another M5 stick C. Go to flow. So I have put this M5 Core 2 in the USB mode, and I have changed this host to Raspberry Pi local. Let me refresh this, and then I'll upload this one. So now the messages will not go all the way to AWS income. Now this programming is done. So I'll go ahead and I change the program for the RFID. So what happens in here is, let me open this one, devices, RFID, open. And even this one, I don't want it to connect to this endpoint. Instead, I want it to connect to. So here we are just like doing Raspberry Pi dot local, and we will also make sure that we select the right COM port once we have connected to this in the USB mode. So need to make a little changes here. Okay, now that we have connected it, so select it and then okay, it has also got connected. We'll make sure the key file is private key and the certificate is this one. Everything else remains the same, only the host changes from AWS to the local Raspberry Pi. Okay, now that this is configured, I can go ahead and then upload it. We know that the messages are getting exchanged in the topic called Rescale RFID POP. So let me publish to that. Let me subscribe to that topic as well. Rescale RFID slash POP. What I want to show is like when this is turned on, we have subscribed, but let's say if I tap any card, the messages are not coming to AWS IoT Core anymore, but the actions will actually be happening. If I tap the M5 stack card, let me reset this device. This RFID thing is working, and this has also begun working. Now, sorry about that. So I just completed programming this M5 stick C, and then now what I'm trying to do is like, if I tap M5 stacks card. This has got connected. Maybe I need to create a subscription such that from one device to the other device, there is the data flowing in. So I'll go to Greengrass, add a subscription, and then I do from devices RFID to it has to go to light bulb. And this one needs to be in the skill RFID and then PU. Okay, next finish. Actions deploy. Okay, so this is like a local subscription that has happened. One device sends and the other device gets it. Earlier, when I didn't have this subscription, it didn't work. Now that I have added this subscription, once this deployment gets completed, then the messages should actually get transferred. So that if I place M5 stacks card, which is this one, okay. For M5 stack card, it is like working. For the other card, it will not be working, as in like the light gets turned off. And if we look at the messages, we should be able to see that like no message has made its way to IoT core. This is exactly what we wanted, what I wanted to show. So what is happening is like all the communication is being handled by the Raspberry Pi itself. Now that we have configured this, which is like good. So I will now get rid of this RFID thing and this M5 Core 2. And what I will also do is like the other M5 stick C device that we had, I will modify that as well so that instead of that communicating with AWS directly, I will make it communicate with the Raspberry Pi. Okay, let's put this in the programming mode, select the device. Okay, and then let's select the key file. All good, Raspberry Pi.local, which is good again, and then we will download it. Now, what is going to happen is like this device, both of these devices that you see now, they are sending data to Raspberry Pi actually. And because we have that subscription in here, which says like ENV monitor to IoT cloud, that's the reason why they make their way to IoT core. Since we saw like how we can locally control the light bulb from RFID, we will look into how we can have these environmental monitors send data to AWS Greengrass. It was already coming, but in ENV Monitor 1, which is M5 Stack C based, M5 Stick C plus based, it has timestamp that starts from 2000. We need to like reduce the number of seconds in them. So what I have is like I have a lambda that is already there. So what I'll quickly do is this folder and this file what we have, I'll compress this. So I have archive.zip, which is okay. Now I'll go to Lambda and then I'll create a new Lambda function. I'll call this timestamp change. And then this is based on Python 3.7, which is okay. Create the function. And once this has created the function, we can upload the file that we just changed. So I can click on upload from zip file, whatever I just archived. So in timestamp change, I have this archive.zip. I open it and then click on save. So it will populate that Greengrass SDK as well as the Lambda function here. And in Lambda function, a few things that you need to be mindful of, like just get rid of this import by MySQL. It's not relevant here. And it usually has like timestamp added, so we need to negate it. So I'll just like do minus here. No, 1970. So I need to add it. So save it, deploy it, and we can publish this now. So when we publish this, just click on publish, and then this has created this as version 5. Now what we can do is like go back to Greengrass, go to Lambda, add a Lambda. It's an existing Lambda, so I'll select that. Click on this, click next, and this is version 5. With the same name, I had one more function already, so that's why it starts with version 5. Anyway, ignore that, and then we go back to subscriptions and we add the subscription. So from our environment monitor 1, we want data to go to this Lambda function, and it has to happen in whatever topic it is publishing in. Either I can put hash or I can be mindful, and then I can say reskill env monitor 1 slash pub. Okay, next, and then finish this one. And from that Lambda function, when it, oh wait, I had to change that Lambda function's code as well. I mean, I had to put the topic in there. So edit code, I will do this thing. So come back here and then put the topic here, which is reskill slash env monitor 1 slash pub. Save it, deploy it, and then I will publish this as a new version again, which will become like version 6. I go back and then I get rid of this subscription first because it will publish to version 5. And Lambda as well, I need to go change it, edit it to remove this version and then add a new version, which is version 6. Okay, good. And then we can update it. And once that happens, we can again go back to subscriptions, add the subscription. So from env monitor 1, we want data to go to this Lambda in this topic and then finish. Similarly, from the Lambda function now, we want data to come to IoT cloud in that same topic. So finish it. And one more thing we want to do is like the env monitor 2's data, we want it in IoT cloud directly. And it publishes in this topic, so we can make sure we have all the subscriptions we need, and then we can go ahead and then deploy it. This will take a few seconds and then that will get deployed, and we should see our values come in here. So currently I'm like, I have subscribed to all the topics. So even the green grasses thing, it will be showing up here. Okay. So here it says, okay, these are messages because it updates the green grass group. We get these messages. Okay, it's successfully deployed, which means the data should start coming in. I will just reset this as well, restart the devices. Okay, from the ENV monitor 2, we are getting the data. Let's quickly check what's with the ENV monitor 1 because we are not getting the data. There are like ways we can do that. So I can do as a root user, I can go to log user US East 1 and then cat no module name lambda function, but it's there. Let me quickly reset my device. Okay, now you can see that. Let me pause this and then you will be able to see that the timestamp has added. Just like how ENV monitor 2, it has 1627846. It also has like similar value, which means that it is counting its time from 1970, not 2000 anymore. Now that this data has started coming in, which is what we wanted, here it goes to IoT Core. There are ways of how we can store that data locally in the Greengrass thing itself. Like there's like one more Lambda function that you can explore. So it will store it in a local MySQL database. Now what we can also do is like have one more Lambda function. Let's say we want to store these messages locally, and then maybe we want to have a lambda function that runs periodically and then it aggregates the data in the last 1 minute, last 1 hour, and then sends it to IoT Core. Stuff like that is also we can do. So how do we work with this local, this script? So in that same folder where we have everything, there is also a lambda which is called local save in MySQL. So what we need to do in Raspberry Pi is we first need to have certain things, but to begin with, what we can do is like there is this SDK and a lambda function. We need to select it and then we need to compress it so it becomes like a zip file, and then what we can do is go ahead and then create a lambda function first. Okay, I want to call this local save in MySQL, and it's based on Python 3.7. Okay, go ahead and then create the function. Okay, the function is here for us. Now let me upload that zip file. Then click save so it gets uploaded. And then we should have this Greengrass SDK as well as Lambda function here. Now, if you notice in this Lambda function, we are going to we are going to store it in a local MySQL database. That's the reason why we have this PyMySQL in the script as well. We don't, if this Lambda were to run on the AWS Lambda, then we should have had a layer that allows us to work with this thing. But what we need to do now is like we need to have MySQL running on in the Raspberry Pi. So we will quickly go ahead and then install it. So I'll do sudo apt get install MariaDB server. this will download and install MariaDB, which will allow us to have a MySQL server running in this Raspberry Pi. While this happens, we can go ahead and then we can actually publish this and then make it, deploy it in the Greengrass group. So I'll click on publish new version and let it be, and then I'll just click on publish. So this gets published. And once this gets published, I can go back to Greengrass and then click on Lambda and add this Lambda, not create a new Lambda. I should have done use existing Lambda, and let's call it local save it MySQL. Next, it has only version 1, so select it and then click on finish. Okay, so it has saved here. Now we can go ahead and have a subscription. Let's say I want to do this. All the messages from the device env monitor 1 goes to this local save lambda, and it usually publishes in this topic 3skill slash env monitor 1 slash POV. If we don't want, if we want all the messages that are sent by this message to actually get saved, we can go ahead and then just put hash, but I'll have this anyway. Click on next and then click on finish. Similarly, let's say I want to save the things from env monitor 2 as well. So it has to go to this lambda, and then the skill slash env monitor 2 slash pub. Okay, next review, finish. Okay, now that we have done all of these things, the only thing we have to make sure is like the MySQL is running on this Raspberry Pi, and we need to make sure that some of the dependencies, like when we look at the code here, we need to install PyMySQL, and we need to in that database we need to have a user called lambda that should be recognized by the password abc, and then we need to have a database called IoT data in that, and then we also need to have a table called records. Once we do all of these things and deploy the Greengrass group, the IoT devices will start sending data to the core will trigger the lambda, and all of this will get stored. Okay, now that MariaDB is installed, let's check if it is running. Okay, 3306 is on. The other way we can check this is like sudo systemctl status MariaDB.service. This should say that it's active and running, which is good for us. Now what I will do is like I'll log into MySQL as root. Okay, now that I'm in, the first thing I need to do is like create a database. So let's do create database IoT data. Okay, that should have got created. And now let me create a user. Create user. And I want to call this lambda. This should be available only locally. So I'll do so lambda localhost identified by the password was abc123. Okay, now this should have created a user, and then what I will do is like grant all privileges on IoT data database and all of its tables to lambda at localhost. Okay, this should have like done all of those things. Now let me exit from here, and now I'll try to log in as sudo, not sudo anymore. I can just do MySQL user lambda and then password abc123. Okay, I'm in as that user now. I want to use the database called IoT data, and once I'm in here, like I want to create a table, so we will do like create table. It's called records, and it should have certain fields in it, like timestamp, temperature, pressure, device ID, and humidity. So what we will do is we will have all those things: timestamp, temperature, humidity, pressure, and device ID. And I need to specify the values in here. So timestamp in this one, it currently comes as like an integer. So what we need to do is we need to have like MySQL number data type. This will tell us like for more than 10 digit values, what type of integer can we have. I think we can go ahead with big integer so that it will allow us to store a lot of values. So the values go from this one. Okay, this big integer is what we need. I mean, integer is also fine for us because that's also 10 digit, and then it has like we will not have like minus negative values, but it basically has like more than 10 digits. So I'll just say timestamp can be integer, temperature, I'll let it be integer again. Similarly, humidities, not integer, these ones need to be float because they have decimal values. So temperature should be float, humidity should be float, pressure should also be float, and device ID, it's a varchar that can have maximum 20 characters, let's say. Okay, the table is created now. So if I do describe records, it has these 5 fields, which is good for us. Now we can look into the lambda. What this will do is like it will insert into records all these 5 fields. Now, every time the device publishes data to this lambda, it will be in this event uh, variable. So we are extracting only these 5 values from that and then inserting it into the database. Okay, we have everything we need. Like, just to begin with, like we can see if there are any values in it. Select all from records. It should not have any records as of now, but we have prepared the Greengrass group with the lambda and all the subscriptions. Okay, one more thing I'm missing is we need to install PyMySQL in this one. I'll just like hold on to that and then I'll show you how to debug it and then make it work. So we will deploy it for now, and then this will start work. So all of these are inbuilt, which will work with the existing Python 3.7 Greengrass SDK. We are attaching it in this Lambda, so it's also there. By MySQL, we have not installed it on this one. And Greengrass SDK, it works with this IoT data, and then we are specifying here that this is how it has to, I mean, the program has to establish connection with the database. And since we have logging enabled here, logging basic config, all the debug stuff, we will get to see if there is any error running this one. Okay, successfully completed. Now, if I come back, what we are expecting is like these two devices should have started publishing data to Greengrass core, and the I mean it should the subscriptions should trigger this lambda function, and that's how it should keep saving the value. I mean, it should keep inserting the values or the records in that database. So if I select now, it should have more values, but we don't have it. So let's see what could be wrong. Now we come back to the Raspberry Pi's console, and then there is a folder in this Greengrass GGC called VAR. Now in this VAR, if we want to access that, we need to have root privileges. So we will do sudo su, and then we will look at uh, what is there in it, what has been logged. So I can do sudo var, and then I see there is log and then there is state. I want to go to log, and it has log for system level operations and user level operations. Lambda is something that the user has deployed, so we will go to user, and within this one, like, we will have that region, account number, all that stuff. So we will do sudo us cd us east 1, and then cd the account number, and within that we have these logs, and we have this. We should have also had the other log. Let's see what's there in timestamp change. So it looks like the lambda is not triggered, but we can also check if the lambda has been deployed. So let's see that. So cd lambda, and then, okay, there is this local save in MySQL. The lambda is already there. cdpr, let's clear it. Login as root, cat. In the current directory, go to var, log user. Okay, this is not generating any log value. So what I'm going to do is, like, since I know what could the trouble be, I'll just like install PyMySQL in there. So I will do exit, and then I know when we run Python, it is like Python 3.7 in here. So I will do Python 3 and install PyMySQL. It does not have pip either. Okay, so I can do sudo apt get install Python 3 pip. This should install the package manager. Okay, now that the Python, I mean pip3 is installed, I can go ahead and then do Python 3 pip install PyMySQL now. Okay, this is successful, and I'll quickly do this, like go to core, cd core, and then in here is where I have this Greengrass SSD. I'll stop it and start it. Sudo dot slash greengrass stop. So this should have stopped everything, and then now I will do start again. Okay, now that this is running, I'll quickly reset my IoT devices as well. So what I now know is that I have deployed, I mean, we deployed the Raspberry Pi, I mean, the Greengrass group uh, already. If I go to MQTT test client, clear it all, and then resume it, I should see messages coming in from both of my IoT devices. So from ANV Monitor 2, we have the data, and we should also start getting the values from ANV Monitor 1. Okay, so the subscriptions are working so that we are getting data to IoT Cloud. Now let's uh, go to MySQL again. The password is 123, and then use IoT data, select all from records. Okay, we don't have anything yet. Let's see if cd dot slash, and then there is where, and then there is log in it, and there is user, and there is local save. In MySQL, that log has started coming in. If we look into it, it says failed to initialize by MySQL. I think what we need to do is, like, we have installed PyMySQL in the Py user, but I didn't do it in the root user, so we will do that as well. So Python, since I'm currently in the root user now, Python 3m pip install PyMySQL. Okay, this is installed now, so I'll quickly go back to cd dot slash core, and then in here I'll do greengrass stop, and then we will do start again. So now the Greengrass group should start running again, because there is this disconnectivity and then starting of the service. It should not really affect the IoT devices, because as soon as it comes back, it should, I mean, the devices, depending on what type of code it has, it should automatically discover the Greengrass group and then start publishing data to it. Now I expect this to have the data coming in into the MySQL. Let me quickly check this one again. So I'll do var log user for this one. It shouldn't be cd, this should be cat. And okay, there's like no log currently. So I will see if MySQL user lambda password has started getting in data there. Yeah, you can see that the data has started coming in. There are like 47 rows, 47 records currently. It's getting both values from environment monitor 2, monitor 1. We can do whatever we want to do. Like we can write queries, and similarly we can have like one more lambda function, and that lambda function can as well uh, be triggered periodically. And then what it can do is like it can look into these values from a particular device, aggregate all those values, because currently these devices are publishing the messages once in 5 seconds. Let's say we want to aggregate it by minute, and then we want to send it to cloud. So not every 5 seconds we want to send it to IoT core, but maybe we want to aggregate it in Greengrass, have a local storage for a day or two, depending on whatever is the requirement. And then we can send all that data to IoT core. And in IoT core, we know like we will follow it through how we can store the data in IoT analytics and visualize in QuickSight and all that stuff. So this is about how we can save data in locally as well. Now let's move on to the next service, which is like AWS IoT device tester. So what happens in this is like when we develop a firmware for these microcontrollers, AWS has a device that checks for its integrity, security, all that stuff. And that gives us like a good idea of how well are we developing our firmware. That's what IoT device tester is about.